Okay, so if a, b, c are three consecutive terms in the expansion of 1 plus x power n, then find n. So maybe I can assume like a equals to let's just say n choose r, and then b is actually n choose r and then x power r, and then b is n choose r plus 1, x power r plus 1, and c is n choose r plus 2, x power r plus 2. So like you will get a upon x power r, just call this like a dash or maybe capital A. So capital A, that is n choose r, and then you also have like a upon x power r plus 1 equals to capital B, sorry, b upon x power r plus 1 equals to capital B is n choose r plus 1. And you also have like this c stuff, so c upon x power r plus 2 equals to capital C is x. Okay, so you got n choose r plus 2 over there. And what can we do? Well, maybe we can use the following identity. So you have like n choose r minus 1 is, sorry, n choose r upon n choose r minus 1, right? So n choose r upon n choose r minus 1, that's like you can actually derive this easily. So n factorial upon r factorial and stuff, so it's going to be upon r and n minus r plus 1, right? This is very easily derivable. Just do some algebra. Okay, so with this identity we can tackle this problem. First of all, I want the ratio of n choose r and n choose r plus 1, so I will put r plus 1 over there. Okay, so it's going to be n choose r plus 1 upon n choose r is equals, when you put r plus 1 instead, so you get n minus r minus 1, so n minus r upon r plus 1. Nice. And then we can actually substitute the values. So this is going to be n choose r plus 1 is just b, this boy is a, it's actually n minus r upon r plus 1. Nice. And similarly we can actually, maybe we take the reciprocal, that will be better, right? Whatever, we'll just continue with this. And then we also want the ratio of b and c, so n choose r plus 2 upon n choose r plus 1, if you put r plus 2 over there, so that's going to give me n minus r minus 1 upon r plus 2, right? That looks correct. So r plus 2, that corresponds to c, this guy is b, so c upon b equals to n plus r minus 1 upon r plus 2. Okay, so well, now what? Now let's simplify these. Let's see if we can somehow eliminate the value of r over there. Somehow we can eliminate r from this thing. So let's add 1 on both sides. So it's going to give me like b plus a upon a, that will be, if you add 1 on both sides, you get n plus 1 over there, upon r plus 1. And then over here you will have c plus b upon b, that will be that will also be like n plus 1, and you have r plus 2 over there. So let's take the reciprocal and subtract. That will get us rid of the value of r. That will get us rid of r. Okay, so b upon c plus b minus a upon a plus b, I think. So that will be like r plus 2 minus r plus 1, which will be 1. So 1 upon n plus 1. That's it. So now we can actually find the value of n. So let's simplify maybe, or let's not simplify. Yeah, so n plus 1, that is equal to 1 upon all this stuff like a upon c plus b minus a upon a plus b and stuff, and like subtract 1 on both sides, it's going to be 1 upon all this stuff minus 1. And then you can put the value of a, b, c as we defined them, so like a upon x power r, b upon x power r plus 1, and c upon x power r plus 2. And there you go, you got a formula which doesn't look very satisfactory. Maybe you could simplify it and then it will be usable, but I think it's better to just derive it every time. So yeah, I will see you in the next one.